So we're looking at page 203. And remember when we discussed investments and we had the formula and many of you did not correctly apply the formula. So A equals P1 plus R over N raised to NT. The formula was handy, right? Everyone had this formula. You put something like T in here, then you wrote just T instead of N times T and all sorts, and it was sad to see that because this was just an easy plug and chug. Okay, so also I showed a formula that we did not use. So remember, this was for N times per year. Compound interest, right? We know that. Everyone knows that. Here is continuously compounded interest. So I would like to apply that, let's say 15 on 203. I'm showing similar problems with everything that you should know. Okay, so we are given P, 10,000, that's the principal. We are given the interest rate as let me write it as is, and T equals 18 months. So one thing we need to remember, what did we say about T? What was T in here? I know we did not talk about this. I just mentioned it, but I didn't do anything with it. But what did we say?
It was the number of times per year. It was in months.
That's N.
No.
That's N. Perfect. That's N. But what about T?
T was just the number of years.
Exactly. So please remember that. So this is tricky. They're telling us 18 months, but we have to change
1.5.
1.5 years. And this has to be changed into
%. 0.041.
Excellent. Okay, so now I'm ready to do that. So the accumulated value of a principal of this at this rate, interest rate, continuously compounded interest for 1.5 years will be 10,000 e to 0.041 multiplied by 1.5. No one can do this by hand. I'm going to share my screen. So let's do this together. So get out of there. I don't know. I don't remember what I was doing. Yeah, our problem was shown earlier today. Okay, so 10,000. Because it's just one, I'll make Kimmy happy. She told me not to put it in the function. So now I'm doing what she asked me to do. Happy, Kimmy?
Well, I didn't ask you not to do it. I just asked why we did
I
it.
know. I'm trying to be funny. Okay. So it's a habit. I just want to see the function in there. 0.30. Okay. It's easy to find my typos if I put the function in. Okay. So in 1.5 years at 4.1%, 10,000 will change into 10,634.30. Any questions here? Okay, next question, next problem.
Sorry.
Yes?
It's just kind of a nitpicky thing. So it was 10,634.3. You rounded it to 0. Why wouldn't it be 3.1? Because if you look past the 0, it is a 4, but there's a 9 after. So
4 rounds down, because you only have to round to 2 decimal places with dollars.
But the 9 will round the 4.
To a 5, and then the 5 would round to a 1.
But
if you're rounding more decimals, wouldn't that make a difference? But if it's dollars and you only have 2, then you take the third after the decimal to use, right?
Yeah,
yes.
The reason I'm asking is because even though you're rounding to only 2 places, why, as it goes further back, would you not round?
Okay, so I can round the 0 to 1. only if this number is 5 and above. If it's 4 and below, I cannot.
Yeah, but what? Okay, so you just ignore the 9, 7 after.
I only round the second digit. If the second digit, if the third digit is 5 or above, then I will change this into 1.
Okay.
Very good question. Good. So back, let's take a look at domain. I want to talk about domain. Of course, not of exponential, because that is always all real numbers. Domain of log. Any log will stick with natural log. So let's say I have natural log of x minus 3. This is our function, and we're asked to find its domain. Okay, in general, so let's write the exponential, is defined on all real numbers and takes values on 0 to infinity as we saw on the graph. Can anyone give us the domain of log in general? Don't look at this function yet.
Do those like 3 numbers we had up before be the ones that we have to take out of it?
I just want you to, for now, to reverse these two as we discussed. I just want to hear that.
I believe it will be 1, comma, to infinity.
I
Isn't
cannot,
it
I
zero
can,
to
I
infinity?
cannot change. I cannot change, and I cannot start at 1.
Is it 0 to infinity?
0 to infinity. Between 0 and 1, I have so many numbers that we don't have enough life to mention them. There are infinitely many numbers between 0 and 1. We cannot miss those, right? 0 to infinity and negative infinity, infinity. So what do I understand from this is log is not a friendly function. What I like to call friendly is a function like f of x equals x squared. Quadratic for me is friendly. I don't have to worry about its domain. Log for me is not a friendly function because it's not defined everywhere. I have to worry about it. Like the square root. I know nobody likes it, but I have to worry about it. I have to write that x minus 2 has to be greater than or equal to 0. I do like the cube root because I don't have to write anything. The cube root exists from anything. So this is negative infinity to infinity. So now whenever I see log, I have to worry about it. So then what do I have to write and then find that will help me find the domain?
X minus 3, it will be more than 0.
Excellent. That's the answer. Thank you. Exactly. I have to solve this based on the fact that whatever I apply natural log to, this quantity has to be between 0 and infinity. So that's how we write it. Exactly. So then x is greater than 3. So the domain of this function is positive 3 to infinity. So keep in mind, log is not friendly. It cannot be applied to anything you want or we want. Okay, so I'd like to look at 57 as an example of this. Any questions for me? Again, all this is nothing to do with calculus. This is just review from previous classes. I didn't teach you anything. This is all that you knew already. So let's look at 57 on 204. Then we have g of x. They're saying natural log of x plus 2 plus natural log x. And the question reads, find the domain of each log function and then graph the function. No, we don't need to graph. And I'll assign a problem like this. You don't need to graph. We're not ready for graphs yet. Not for something like this. We are ready for a graph like this. Yeah, we're ready for a graph like this, but the sum, just punch in the calculator. Okay, so This function is composed of a sum of two functions. So let's take it one step at a time. Can anyone tell us what is the restriction? What do I have to write to find the domain of the first log function?
X plus 2 is greater than 0.
Excellent. Now forget about this one. Let's talk about this. In a moment, I'll come back. Yes, of course.
X is greater than 0.
X is greater than 0. Remember, for this function to exist, both functions have to exist at the same time. If one exists and the other one does not, then the function is undefined. If this one doesn't and this one does, the function is undefined. Both have to exist at the same time. So what I get from these two, I have to intersect to find the domain. Okay, so of course you already told me x greater than -2, and when x greater than 0, I have to intersect these two. Let's say we don't see where what. Okay, fine. So let's take a look at the real line. I'm going to graph x greater than -2. And I'm going to graph x greater than 0. And I would like you to give me the domain of this function.
0 to infinity.
Brilliant, because we have to look for both colors. Where I have both colors, they both exist at the same time. If I choose this piece, only the first one exists and this one doesn't. If I choose here, none. So thank you very much. The domain is 0 to infinity. Done. Okay, let's look at some more problems unless you have questions for me. Okay, let's look at bacterial growth. 79. Yes, bacteria, as you've noticed, viruses, mice, rats, bats, they grow exponentially. Okay, so a biologist swaps a sample of bacteria into a petri dish, and the original colony covers an area of 2 millimeters squared. Every hour, the colony area increases by 4.5%. So the rate is 4.5%. Write a function of the form. We know the form, we don't have to. So A of t equals the principal. In this situation, it's not the principal, but the initial count of bacteria, of course. Is the same formula, same function, same function. Okay, but this time, this is the initial count of bacteria on the petri dish. R is the growth rate, same like with, okay, and T is time. So now, here T is in hours. Okay. So they're asking us to find, they're telling us that covers the area. Okay. That gives the area of the colony of bacterial. Okay, so in our problem, this is the area. And the initial, it's not the initial count. It could be, but in this problem, they're not giving the initial count. They're giving us 2 millimeters squared. Okay, so in part A, they're asking us to write the formula. Write a function. No problem, I have everything. So this is A of t. I will replace P by 2. I will have E. I will have the interest rate, of course, the growth rate. How do I write it? Because it cannot be in percent.
.045.
0.045, 0.045 times T. This is done. Now in part B. In part B, they say, what is the area of the colony after 10 hours? How do I determine that? And then they have, when will the colony's area reach 50 millimeters squared? And when it will double. Okay, so I'm asked to find what happens after, in 10 hours. What would you recommend?
Plug it in.
Yes, of course. So A of 10. So 2e2 point, I'm multiplying this by 10.45. Okay, I'm sharing my screen so we can plug it in. So 2 times e to power 0.45. Okay, 3.1366. So I'm going to write 3.14. 3.14, and this is in millimeters squared. It's the area. Okay, in part C, they're asking, when will the colony's area reach 50 millimeters squared? What do I need to do now?
A of 50. Plug
Very
it in.
good. 50 equals, no, A. This is the area, right?
Correct. I'm
The
sorry.
area, that's okay, is 50 equals 2e to 0.045 t. They're asking us to find t, the number of hours. So what do I do now? How do I solve this?
Is that when you take the inverse of it?
Yes, but it's not ready.